actually understand that myself.
You don't know that phrase?
Well, I
Um,
just don't
yeah.
think it's very classy to use that sort of terminology. We're just going to have I would hope, a respectful discussion. But if it's not going to be
We're
that
not
way,
in a
then I will
even though
leave.
it's the only way to put it, man.
Yeah, I just, when you're trying to get to know people and have this conversation,
Well, let me warn you, Baron. Have you ever been in this Discord before?
never. This is my first time.
This Discord is very degenerate. So,
Then I'm out.
not on our side. I'm not saying it's this chat, this Discord in general. It's the politics Discord. So you get a lot of immature. They'll come in. They'll say the N-word. They'll say some stuff against Jews. They do these drive-by trolls. So I'm just warning you. Don't be shocked.
Yeah. So I have a responsibility to own my behavior, which is 100% my choice. And if I can't do that as an adult, then I shouldn't be engaging in these conversations.
Well, it's going to have nothing to do with us. This is an open chat. People can just join. And they see flat Earth and they get triggered and they come and they just yell some crazy stuff. That has nothing to do with the conversation. They're not flat earthers. They're just speds.
Oh, okay. It was pretty hard for me to get in here. Like I had to do a lot of I had to get interviewed.
Really?
Yeah.
Man, damn.
Yeah, I had to do this VC verify. Some guy had to come talk to me and ask me about, my flat Earth experience and what have I done to verify the shape of the Earth. And
oh, you mean in the home server?
This with
I think
the 24/7
so.
home server.
Yeah, that's because we live stream on YouTube, so we get people that would just come in and scream expletives to try and get the YouTube channel nuked. So we had to introduce a screening process.
Gotcha.
Though I deprecated that, so I don't know why someone's still doing that.
Well, yeah, and there's also people trying to evade bans and stuff like that, right?
Oh, yes. 200 plus, 300 plus alt accounts. There's a guy we finally named PD because he comes and advocates drinking pee and not using soap or water or anything like that, and that he's using the internet from the Garden of Eden. Yeah.
Well, roger that.
This morning, Discord is not TikTok. I mean, there's some weirdos on TikTok, but man, there's no accountability on Discord for some reason.
Interesting.
I mean, I remember back in the day, all the mods in our server, we got autopsy photos for something like 2 months. Every day we'd get spammed autopsy photos in our DMs. Yeah, he didn't like us. Whoever that was. I'm not squeamish, so it didn't really bother me that much. Though, I'm not going to describe one that did bother me. But I mean, if you hang around, Yoder will be back. I'm just very like, I need more caffeine to engage in this crap. But I will post a couple citation about curvature of the plumb.
Yeah, it's I think there's
and a diagram.
There's some yeah. So these things are sub-millimeter, and it's considered deflection of the vertical.
Yeah.
Right. It's the difference. It's the angle between the true plumb line, which is influenced by local topography, and the normal to the theoretical reference ellipsoid. And generally, it can get up to about 1 arcminute, which you'll see in your Laplace corrections via like phase differential GPS leveling and stuff like that. Yeah, that would be a pretty exaggerated example. there's an angle there, right? That takes place.
Yeah.
And so what you can do, and I did this out at Fort Funston. I went out there to meet a group of guys that wanted to learn how to measure the Earth. And so what I did was I took a 60D nail, it's a common nail in surveying for construction staking, because that's primarily what I do. And you hammer the nail in the ground, and then what you do is you set your tripod over the top of it, and you use usually about an 8-minute tribrac. And you can get more sensitive to that depending on what you're trying to do. There's an optical plummet on it to where when you look through the peep sight, it shows you a 90-degree sight to the nail with a circle and a crosshair on it. And so the idea is to center the instrument directly over that point. Now, when you do that just out in the open with nothing around and you hang a plumb bob, the plumb bob will just drop right to the center of that nail. But if you do this at like the base of a mountain, you'll notice that the plumb bob will pull towards the mountain. So it's like, okay, that's what they're talking about, that angular deflection between what would be considered vertical and plumb. And this is why we got away from the North American vertical datum of 29 and got into NAVD 88 and derived orthometric heights. It comes down to leveling, right? And how surveyors have to account for the curvature of the Earth via the leveling process, right? Like trigonometric heighting and things like that for obtaining the heights of distant peaks that are virtually intraversable.
Okay. That's not what deflection of the vertical actually is, though.
Well, can I hear your definition of it?
Okay. So you have your celestial sphere.
Mm-hmm.
So imagine there's a star that's supposed to be directly overhead at zenith.
Yep.
And you have I can't remember the name of it. I can't remember the name. It's for astrogeodetic surveying. It'll look straight up. So now say your coordinate is supposed to be exactly underneath the star. That star is supposed to be at zenith. But when you sight in zenith, that star is off by a little bit, arc minute, whatever it is. Right? That's the deflection. It means even though your instrument is level, right, where you're at, the gravity vector is not aligned with the celestial sphere.
Yeah, one is vertical and one is plumb. So if you were to draw a straight line down from that star through the center of the Earth, and then you were to occupy a point, geodetically speaking, which, these are referencing to geographical points. And the reason why they come up in geodetic surveying is so that we can transform those coordinates to what are called state plane coordinate system. So that we
How
can map
important
out
is it,
our
Baron,
state.
for the clock to be synchronized and accurate with sidereal motion?
I don't know.
Well, that's actually necessary for determining deflection of the vertical.
No, I'm talking about the angle from down and vertical.
Yeah, I'm talking about the astronomical plumb line.
Yeah, that's not what I'm talking about here.
That's dependent on clocks.
Okay. So go ahead and explain yourself and we'll work out the math.
Well, I'm just adding some further clarification and detail so you understand that you're talking to people who kind of know what they're talking about too.
Sure. I'm actually a professional land surveyor and can go out and measure this stuff.
Okay, so you're not a geodetic surveyor then?
Everybody's a geodetic surveyor. Anytime you measure a distance along the ellipsoid, you're a geodetic surveyor.
You don't measure along an ellipsoid.
Why don't you?
Because the ellipsoid is a mathematical concept. It's a datum. It's not something in reality, unless you want to reify it yourself, which would be fallacious.
Sure. You can set up, you can use 2 orientation marks, one that you can set up on. You can use a back azimuth to get your orientation, and then you can measure in the shape of an L, either using EDM or chain the distance. And you'll find that the published grid-to-grid mark distances are different than what you measured on the Earth.
Yeah, exactly.
And you could do this out at the Bonneville Salt Flats. That's what I did back in December, actually.
Yep, everybody knows electronic distance measurements don't match coordinate distances.
And why is that?
Because Earth is flat.
I know, but which distance is longer? The distance along the ellipsoid or the distance along the chord?
The distances in real life taken electronically don't match spherical distances. unless you pin them to an ellipsoid to match them, but in which case you're no longer using real world measurements anymore.
No, I'm
You're
talking about
altering the distances.
chaining. I'm talking about chaining the distance. You know what a Gunter's chain is?
Well, chaining tangent planes.
No. You know what a tangent plane is?
Yeah, that's also
What is it?
with respect to a mathematical datum that doesn't exist in reality.
No, a tangent plane is
Yeah, a datum like
point.
WGS84, a tangent plane to WGS84.
No,
You can chain tangent planes together.
So
That's how
unfortunately-
GPS works.
Unfortunately, I'm gonna have to disagree with you, but that's okay.
Okay, well, I can point you to an online Geodesy Academy that you can take some lessons, go learn about this shit if you're interested.
Sure, go ahead and link me up. We'll check it out.
Okay,
sometime.
I'll give you some links. All right, I got to step out for a minute. I'll post it.
Okay.
So I know what a Gunter chain is.
Yeah, so a tangent plane is the projected plane where the tangent plane itself is brought to the height of the instrument. It's the point where the horizontal line touches the surface of the circle. That's the tangent plane. If he's talking about tangent plane projections, that would be something completely different.
Ah.
I don't know. I'll have to explain it when he comes back. I'm not 100% sure of exactly what he's referring to. I have an idea, but I don't want to put words in his mouth.
Yeah, so that's how we know that there's drop, is because we can establish the tangent plane, and then we can turn angles to distant targets, and then we use that tangent plane as the reference. It's considered eye level. And so you can either use this in the process of direct differential leveling, which like in any surveyor's field book, like I've got a bunch of them sitting here. If you look in the back, it will give you like what are called useful notes. And it will tell you that the curvature of Earth's surface is about 0.7 feet in 1 mile, and the curvature in feet is 0.667 times the distance of miles squared. And it's got a bunch of stuff in here, right? So basically what that means is if I set up my instrument, say, generally speaking, you want to do it equidistant. Let's say I don't. Let's say I want to test the shape of the Earth. I want to see if this is real. This drop can be measured. I take my rod and my rod man, and I set him up on a known elevation. And that's called the back sight. That's a positive number. It gets added to whatever I read on the rod gets added to the elevation of that point. Then I take that rod guy and I send him out 1,500 feet in front of me. Let's say the back sight's 75 feet. I send him out 1,500 feet in front of me, and I read the rod. That gets subtracted from the sum of the back sight and the elevation. So if I were to minus what I read on the rod, that should be the elevation of that point, but it's not going to be. It's going to be out. It's going to be out about 0.03 of a foot. The question is why? Well, if you were to account for the curvature or the drop from the tangent plane over that distance, you would close, and you would therefore, both geometrically and mathematically close that loop. This is a testable thing that you guys can go do. Like you can buy an auto level on eBay, and you can get a plastic fiberglass rod, and then you could go out and you can test this just to see if it's true.
Yeah, it's not true.
I'd love to see your notes on it, man. I've got a whole book here.
I'd love to see your notes on it, quite honestly.
Sure.
I'd like to see all your measurements, not the ones you kept, but the ones you threw away too. So this goes to the crux of the argument. You're cherry picking data and confirming your bias.
That's your claim. So
it's not my claim. I've looked at all the literature that's tested using surveying methods, right? You said things like we don't measure a concave Earth, right? Remember you said that? The two things I just posted, one of these things, no, not that one. I'll post it, right? So using reciprocal zenith angles, there's a one that's they say right in it, they measure or they calculate a negative K value. That's concave, dude.
Well, all values are negative Ks. So
all values are negative.
So the coefficient
gives a range,
of refraction
negative 4K
is always
to plus 6, right?
Yeah, but it's always subtractive. Wait a minute. You know this, right? Like you've studied a little bit of refraction. You understand how it works in the process of leveling or taking measurements, correct? So if I were to take, let me ask you something. If I were to turn an angle to a distant peak, okay, and I had no idea about my elevation, right? Let's just say that we're clueless about the elevation that the Occupy station is. And let's say I look over 30 miles at a known peak with a brass cap up there. We know its elevation. We know its coordinates. We know it's there because surveyor said it's there, right? How
Yeah,
would
and they
I
assumed the
find?
globe when they did that, right?
How about we just assume a flat Earth? Let's try that. Will that work
Okay,
for
then
you?
you're going to get a different elevation.
Well, I mean, you're gonna. The measurement is the measurement, right? We have to figure out what the shape of the Earth is by using the geometry on both sides. You're saying the Earth is a level topographical plane.
Yeah.
I'm saying that the Earth drops at 8 inches times a mile squared, and you can go check that out. But you'd need to know a little bit about the geometry and a little bit about the instruments and go out and actually try this stuff first. Because me explaining it to you, I think we're just kind of beating a dead horse, right? You've got your ideas about what you're reading.
They're not my ideas. They plainly say it.
They are, though, because you're saying that refraction.
So when they explicitly say that the ray would be concave, that's me misinterpreting the word concave.
I don't know. I don't get plumb lines leaning towards one another, dude. When I do my plumb lines to see if they're parallel or not, that's not what I'm getting. Is what I'm telling you. I don't know. I mean, if you've got somebody that's measuring that, I'm willing to take a look at it. I'm just letting you know from my experience and the data that I have. That's all I can provide for you is the data I have. If you want to say that I've cherry picked or been dishonest in some way, then I guess
No, cherry picking isn't dishonesty. It's a cognitive bias.
Well, it is dishonest, right? If I'm taking a measurement and then not sharing it,
if you're intentionally cherry picking, that would no. Some people think it's all right.
I just go and I measure the data. That's it. I let the data tell the story. I mean, that's it. Like I'm getting ready to meet up with Jaron over in California. Anybody is open to come to these and show me their means and methodology. Show me how to arrive at a flat Earth. I've been all over the United States doing this. I think my behavior aligns with the value of truth seeking. If you guys want to say it's something else, I can't help you. That's just what the data is. So, I've never been to, a surveying conference or met any other flat Earth land surveyors out in reality. I meet them on TikTok all the time. But after we talk for a little bit, it comes to find out that they're not actually land surveyors.
Well, that's fantastic. Who cares?
That's just my experience.
You're just a narrative spinner, dude. That's all I'm hearing.
Okay.
I'm just hearing narrative. That's all.
All right. Well,
Storytelling.
I guess the conversation's over, man. I just thought we would talk about measurements. You say you wanted to see them. I can provide them to you. How do I post them here?
All of them.
Yeah,
Not the ones you just cherry pick. Oh man, the wind is blowing. You know goddamn well that you have to survey under very specific conditions, right?
Correct. So I don't know what you're accusing me of.
I'm not accusing you of anything.
You're saying you want to see measurements that are thrown away.
There's going to be an uncertainty in any measurement.
Every single measurement has uncertainty.
This is uncertain. Yeah, there's a measurement uncertainty.
Every single one of them. What is that? What's E1, E2, and E3 values, respectively?
Oh, God. Okay. Dude, stop. The posturing shit is annoying.
Yeah. All right, man.
It's really simple. There's going to be an uncertainty. The air gives another level of uncertainty, right?
Snowflake that ran off.
He's gone.
Did he leave?
Wow.
That was easy. That's the same way Astronomy Live is. If you don't talk about what he wants to talk about, he's leaving.
Man, I didn't even get a chance to come back. He was going to get tied up in knots anyway. It's obvious he doesn't know what deflection of the vertical is. He thinks he does.
I know. He also said NAD 23 or something was like in 27. So, but that's, maybe just don't remember the number. I'm not gonna.
There was like a
Big deal out of it.
WGS 83 or something right before 84, I think.
Yeah, yeah. It's called
Was it GRS 83?
yeah, WRS 83 and WGS 83, I think.
But the fact that he thinks he knows what astronomical plumb is and doesn't understand how you have to incorporate the time component to this, because how else would you know when the star's supposed to be at a certain point in the sky?
I'm gonna get to post this, man. I'm pissed. What the hell? But he was doing the same thing he did last night. Like, look, here's what the data says. Oh, you don't understand it. Okay. I don't understand it. They say convex, or concave, and I guess I don't know what the word concave means.
Yeah, it means on your own geoid, you're going to have verticals that don't just converge underneath you, but diverge away from underneath you and converge above you.
Exactly. But the point is, he was saying, you go out, you'll measure this. That's horseshit. It's just horseshit. Maybe I'll measure that.
It's going to be positive curvature everywhere, dude.
Well, yeah. He said you're going to measure. What did he say? It's I'm going to measure some amount of drop. Now, what he thought tangent plane was a tangent plane that's running through the theodolite.
Yeah. I mean, it sets up a level, duh. Well, but that's your local tangent plane established from level is not the same thing as what he was talking about, projecting the coordinate system flat. So he was wrong there. The tangent plane, you can set up a tangent plane to a mountaintop that's curving or a hilltop that's curving. See what I mean?
So he's chat skanking now. Really funny.
Is he listening and chat skanking? But yeah, like you can set up flat or a globe. You can set up a tangent plane. Just the tangent in reference to what? There are going to be areas of Earth that have gradual slopes over tens of miles. And you maybe want to set up a tangent plane to take your local measurements, right? It's not the same thing as taking WGS 84 and instead of doing a reduction of the horizontal datum, you do the opposite. I've actually got a video on this. Hold on. All right, check this out. Posting it inside. You can lay your blanket on the ball, and then you can lift the blanket off the ball.
Depends on the size of the blankie.
Yeah. Tangent blankie. Just pull the corners tight, my friends.
Where's the other one? Fuck.
Wow, so he's just gonna chat skank now, hey?
Amazing, right?
That's crazy. I can't believe he left. He didn't get muted once or anything like that. He didn't.
Dude, I didn't even say anything bad to him at all.
And this is their top guy, their top globe surveyor. Amazing.
He has to protect his reputation. He's made quite the I don't know if he makes a living off of it, but he's made. Well, I mean, me and Yoder heard of him, so he's built some reputation behind this. He comes in here and gets cooked. Then
I've watched a bunch of his observations on TikTok where he just completely just guesses the atmospheric conditions every single time.
Very interesting.
Yeah, even straight over the surface of water, right? He'll just guess the refraction.
It's whatever doesn't match the globe, because the refraction is equal to the difference.
Yeah, I mean,
that's literally what this dude thinks. He thinks whatever that is different than the globe, the refraction is equal to whatever difference that is.
And whatever's not in refraction could probably be made up with vertical curving plumb lines, rather. I'm still reeling at that. Like I thought he would know. I thought he would definitely be like, oh yeah, it's important to have synchronized clocks. So how else are you going to get your longitude? Amazing. It's kind of scary, right? When you don't do this for a living and you start to learn more than professionals do about their own craft, it's kind of scary. Like, holy shit.
Well, I mean, when you're doing it as a job, you like, you have your boss cracking the whip, right?
Yeah.
Just go through that thing, write down the fucking number. We have 20 more jobs this week. Hurry up. Good enough.
I don't care that your triangle measures 180 degrees. Curve it.
I mean, I watched them survey a big high rise. They kind of put, well, not that high, maybe 10 stores. But they're out there every day surveying it. Like every day.
Okay.
Some new funny claims by Jesse, Path of Light. I was having a long chat with him today because AI Overlords challenged him with being able to confirm that you're able to actually have no destruction of what you're looking at in the distance, and have a refraction coefficient of 0.96 at the same time, which basically is what would be needed on Dr. John Dee's windmill observation. So AI Overlord's challenging him that he has to be able to validate, right? Show us that someone's actually measured that accurately in the past and shown that you can have that with no destruction, right? No like visible miraging effects or crazy destruction optically. So Jesse's he's made further claims during the conversations I was having with him, trying to explain to him what he needs to actually do and that he doesn't have to do it himself. Now he's claimed that in the he's trying to use the 40 kilometer FE core test. So he's pulled up one of the single vertical temperature and humidity readings. I think it's about 2 degrees difference between the temperature of the air just above the water and then at 2 meters height. And he's confirmed, he's done the calculation. Now he's claiming there's a refraction coefficient of 0.43. And on the FE core laser test day, because of those 2 temperature and humidity readings at one point along the path, not a K factor, not a big K, not a K factor of 4.3. He's saying a refraction coefficient of 4.3. And he's got some other one that he took himself where he's claiming that it has a refraction coefficient of 2, which is Walter Bislin's slider only goes up to a refraction coefficient of 1. So basically for this observation that I just put in the side chat, Jesse is saying that if the Earth was flat, then this boat would have to be 28 feet. He's upped it to 33 now, but in this he says 28. So if the Earth was flat, this boat's 28 feet higher than what it should be. And that proves that there's a refraction coefficient of more than 1 on a flat Earth without any destruction of what we're looking at in the distance. And that's what he thinks is the counter to AI Overlord's request. That means for this to work on a globe, you would have to have about 66 feet. This boat would have to be lifted up from 33 feet below the curvature to 33 feet above the horizon, which would require a refraction coefficient of 2.
How funny.
Which is,
so Walter Bislin's model only accommodates up to 1, which means it can't account for super refraction.
Well, I mean, what's even super refraction anyway? There really isn't any citations.
Oh, the opposite of sub.
I mean, I know, but I mean, but wouldn't even like 0.6 refraction coefficient sort of be counted as super refraction? Like once it gets past 1, that's like extreme ducting. I
think it terminates at 1, approaching infinity.
Well, infinity in regards to
no, it'll go into negative and look concave.
Yeah, that's what
the ray of light is bent the other way.
That's what I'm getting at.
This is what Jesse's saying. He's saying that not only is the boat lifted up 33 feet from behind the curve, it's actually lifted up a further 33 foot because the refraction coefficient is so high. And Jesse says that this is just super common to have these like crazy refraction coefficient. Basically, to have a refraction coefficient of 1, he said it only has to be 0.33 degrees Celsius per meter change in the vertical temperature. I'm talking about Jesse Path of Light. If that's Jesse Gordon, I'm not sure.
Yeah, well, you know, I did tell him not to make observations in this place. So this is the Salish Sea. The Salish Sea is connected to the Pacific Ocean. So tide water flows in, goes up the Salish Sea, and then flows back out. But there's a huge turn, like almost like the Strait of Hormuz. It has like an elbow that turns. Well, if you look at the oceanographic water elevation, there's a big hump right where the turn is, in the middle of the turn, that varies from like 8 to 21 feet. So you're like literally making, because this is the same place he like, look, the sign is above my theodolite. This is literally cherry picking. How many times did he look through his theodolite to take this picture? You know what I mean? This is the same problem I have with the Soundly thing and the Lake Pontchartrain. That dude has taken hundreds of frickin' pictures of that bridge, if not thousands. Pulls one out. Look, the bridge is curved. Yeah, let's show us the other thousands. And that's my beef with Barron here. Hey, if I go out, I'll just get this measurement. No, you won't. No, you goddamn well you won't. Maybe some of the time you will.
Yeah, you know, we should really bring it back to that geometric horizon test. Okay.
Yeah.
When are these people finding this geometric horizon? Right? When are they going out over a distance where there would have to be a geometric horizon at a certain distance, right? With their guessed refraction, right? That they guess. I mean, I've not seen them ever actually measure it, right? So they're just guessing it. They're just using a model and guessing it. That means that the horizon would have to be at a certain distance.
Yeah,
but I see
infrared to control for weather.
Yeah, so I only see them doing, for some reason, right? Jesse Kozlowski, I think I've seen this guy do it as well. They're doing these theodolite tests over short distances, not long enough to where there would actually have to be a geometric horizon present from the height that they're doing it from. And then when they're not doing that, they're doing it from another vantage point, you know, where you wouldn't be able to really make out a geometric horizon as well, which is sort of mountain peak to mountain peak. But when we provide, they're skipping that midpoint where you would have to have that geometric horizon at that set point. I mean, and I want them to show footage of when you have the, you know, a subrefraction, negative refraction coefficient, the horizon would have to be closer. The geometric horizon would have to be closer. And that I've never seen that happen.
I mean, that's what's got to be happening in the lake videos, right? With the RC boat, for there to be a horizon, there has to be some serious negative refraction going on to move the horizon from 2,400 feet away to freaking the middle of that lake, right? Because there should be no horizon on that lake whatsoever. According to those guys, right? If I look over some water, I'll see the entire surface of water till I reach the geometric horizon, and that's where the curve starts. There shouldn't be any horizon in front of that ever.
Exactly.
But like I said, the RC boat videos, they show a well-defined horizon. I mean, you can argue about the boat waves or whatever, but why is there a horizon at all? Right?
Yeah. I actually have a good paper by he was a scientist, but he was also a sailor. I'll find the paper, I'll post it in the side chat. But yeah, he was doing observations. This was a long time ago, in the early 1900s, I think. And he was seeing boats disappearing from the bottom up and even completely disappearing at such short distances. He came to the conclusion that there's absolutely no way this could be caused by the curvature of the Earth. Because
you still got that? That would be cool.
Yeah, I'll grab it right now, actually.
And what they would say is, right, concave rays of light and subrefraction, right? Because they have it in radar, right? They call it subrefraction. But the radar don't go as far as it's supposed to go.
Yeah, so he thought that was amazing, and he went back and he did a whole stack of tests and determined that you can have a nice clean horizon that's not caused by curvature of the Earth at all. Yeah, I'll find that now. Actually, I'll go on mute for a second.
On a related note, their North American Arc of the Parallel document that they love to bring out as a proof. Within that, you can find where they were perfectly fine cherry picking. They describe throwing out streams of observations and measurements. They're not intending to deceive.
Dude, there's a whole section of California they had to throw out measurements for that were all messed up. And they published. That's just like the one they investigated. Oh, let me find it real quick. It's very
other
mountainous
parts too, like the Himalayas as well.
It was like a very mountainous region. So what they said was they were getting what's unequal refraction error.
Oh yeah, you brought that up.
Yeah, looking up through the gradient, it would have a different light path than looking down through the gradient.
Right.
So they were like, "Oh, our measurements are wrong," and it was like a whole section of California. But it's like that was like the place where they did like, "Hey, we're gonna go to this. Like, we did this whole survey of North America. Let's go to a place and double check." And they're like, "Shit, we double checked and it's all wrong."
So on a globe, they think that when they're looking at the horizon, that they're looking at a tangent to the Earth, which means they're staring off into a region of decreasing air density. And meanwhile, the opposite actually happens. I think that's why we see, like, their defined term of terrestrial refraction is the exact opposite conditions of super refraction, but the effects are the same as described. And so this means, when they're looking at a mountain peak in the distance, means that they're looking through a gradient that decreases at a higher lapse rate than as if it were on a flat plane. Just throws everything off.
Well, I mean, like I've said before, man, the justification for even claiming refraction exists is seeing a flat Earth. It's basically the remainder of any equation. Earth equals a globe, and when it doesn't, we have refraction that we're going to fill the hole with.
I'll read
It's
out
like,
a quote from
it's like silly putty.
from this paper. So by bringing the line of sight near to the surface of the water, boats and other small objects are found to be completely hidden by an apparent horizon, which in so short a distance cannot be owing to any curvature of the water, and can arise solely from the bending of rays by refraction. When I reflected upon the causes which were probably instrumental in the production of these phenomena, they appeared referable to the difference of temperature alone. I'll post the paper as well in the side chat.
Nice, thanks. Yoder gave me homework, man. What the hell?
Oh yeah, which one? I give you homework a lot.
In the geodesy freaking thing in the home server.
Oh yeah.
Like, oh man, you took a big ass dump in there.
There's so much stuff there, man. I got to go through all that as well.
I'm tweaking some of it too, just to make it more user friendly. But check out #satellites too. There's
boy. We got homework. God damn it. $18.03. That was a good year.
A lot happened.
Yeah. Every single person that ate pickles that year died.
What?
Yeah, man. Every single person. They didn't die from eating pickles, but
oh,
they
I
all
see what
died.
you mean. Yeah.
See, that I wanted to
You
bring that
got
up
me.
because that's how you lie with statistics, right? That statistic is 100% accurate. I just omitted key information.
Yeah, that's how deception's done. Self-deception, delusion. You ignore information to perpetuate your own myth.
Yeah, you missed it. I don't know if you were here when I talked about cherry picking.
Barely.
And he took it as like I was saying there's something against him or something. Like, no, it's cognitive bias. It's not it can be intentional, but a lot of times it's not intentional. It's just a cognitive bias.
It's almost a Freudian slip, if you ask me.
It's like cherry picking. So there's the normalcy bias, which is a cognitive bias. And if you think globe Earth measurements are normal, how do people make mistakes when they do things? They'll look at something and they'll literally see something that's not there.
The lemon illusion. Hello.
Yeah, people have been in like fires, dude. The whole building's on fire. And they don't even realize it, dude, because the normalcy bias.
Yeah, it can't be happening.
I watched a video of a gas station convenience store. The whole wall is on fire. And the guy that works there, he runs out. But customers are still coming in, shopping, buying stuff. Now there's no cashier and the wall's on fire. And like at least 5 people come in to shop. And one guy standing there waiting for the gas station attendant to, I guess maybe he thought he was in the bathroom or something. Just sitting there waiting at the register. Yeah, they didn't run out of there until the smoke got to the level of their head. And then they were like, and then ran out.
There's another really good paper that I've got here that I'll put in the side chat as well, and it's all about how unreliable and how ridiculous the standard 0.13 standard refraction coefficient is. And they did stacks of tests. It's actually a huge paper. It's a really good paper. But basically, it says the failure of standard refraction. The study explicitly concludes that the frequency used in the Gaussian refraction coefficient of plus 0.13 is unsuitable for describing refraction effects in the lower atmosphere. Basically, the source reveals that near-ground refraction can differ from this, quote, standard by 2 orders of magnitude, and that it kind of shifts constantly. And they were picking up ranges from -4 to +16 on sunny days. And there's a whole section on how temperature is the primary controller. And anything under a certain height, right, especially under 30 meters in the troposphere, is just completely controlled by temperature, basically. Yeah, it's a cool paper. It's interesting. I actually found the paper on Walter Bislin's in the references section. But I'll post the paper as well. There's lots of good stuff in there, actually. It's the Journal of Geophysical Research on Atmospheres.
Yeah, it's like these glimmers of honesty, right? I thought I hit a little jackpot when I found one of Jesse Kozlowski's papers from 2006 describing how electronic distance measuring doesn't conform to spherical coordinates.
It's funny, he interpreted that as the Earth's not flat, which is, there we go, the cognitive bias.
Yeah. Good point.
Right? He like what he said, the chains, right? So they used to take chains and measure on the ground directly by using these little triangle chains. Now, fine, you can do that, but the longest chain length measurement that was ever done is 7 miles. Do you think that you're gonna? What's the difference between the arc length and straight line length that an EDM would find in 7 miles? 2 inches?
Very little.
Half an inch? Your measurement uncertainty, which I tried to bring him up to him, is measurement uncertainty. It's not even precision. Like, precision's a whole nother thing. People think the precision is the uncertainty.
Right.
No, that's not the uncertainty, dude.
I'm glad you're bringing that up because, no, I don't. Jesse's a nice guy, I think, but he extrapolated a globe out of using a measuring wheel over a mile to measure angular change of stars from one place to another. I'm like,
that's an actual issue of precision, dude. Those fucking measurements.
you know,
Jesus Christ.
so you measured 1/25,000th of what you think the globe is, and you've got an accurate measurement. What's your error rate? I mean, if we compound that
with a wheel.
Yeah.
I mean, maybe if it was on a track or something, or it had teeth, or if it was gear, right? Where there's no slippage.
Yeah. How straight was it? I mean, if you start like taking a curve to the left or to the right.
You know, like, it's so funny. They act like these things are so, like this measuring wheel. He wouldn't bet his life on the accuracy of that measuring wheel.
You're right.
Right?
But when it comes to
this cannonball, it's exactly calibrated to 100 feet. Take your wheel and measure to 105 feet, and it'll land at your feet. He would not use that fucking wheel to do that.
That's funny, true.
Sorry, DJ.
It's kind of like too with the gyroscopic precession, right? They'll show you a mechanical gyro, and they'll show a precession that seems to accord with maintaining rigidity as the Earth turns under it. But they'll do it for like 10 minutes. It never account for any other variables, and then they'll extrapolate a globe out of it.
Yeah, it's pretty whacked. Let's see this. Oops. Oh yeah, DJ, I just posted that a little bit ago.
The same one?
Yeah.
Ah, it's out of the same paper. Yeah. You must have already read this paper.
Yeah, seen it years ago actually. Goldberg's. I think I found it first on it, and then McToon ended up putting on his website, and for some reason, for at least a small period of time, Goldberg's were like, "Yeah, here's everything that proves it in this paper." Like, did you read the paper? Because I know if you read the paper, you wouldn't be using that.
Which
And
paper?
they give you a link to McToon.net, and it would be a direct link to that paper, right? Look at all the frickin' refraction papers on McToon's site. Yeah, did you read any of them? Neither did he. None of them support what you're saying. None.
Wait.
They did one in Greenland. They did testing quote unquote refraction model in Greenland. And they took a bunch of frickin', markers, and they ran them over ice, right? So they had the distance and all that, and they measured all the meteorological conditions. Dude, it's not even like they're not even close to each other. And McToon's got that on his site, where they got the graph of the meteorological conditions overlaid over what they actually surveyed, and it's not even close. They're in no way correlated. Correlation 0.
First law of Glurf is you got to quote mine.
I mean, can someone just do that? Show a correlation between the meteorological conditions and what you're seeing through the theodolite. You measure the meteorological conditions, you graph it. You look through the theodolite, you graph it as using the same time, and then you say, "Hey, dude, did these curves fit? Or these slopes fit?" Right? You know what I mean? Like, what's the correlation between these numbers? I've never seen anything. I've seen it attempted, and I've seen no correlation. I mean, there is a correlation, but it's not correlated in the way that they think. They're using like the wrong variables, or like I don't know. Here, I'll get one. It's one I used to post all the time.
Yeah, I'm going to have to include that quote into my railroad videos I have on YouTube.
EJ's done excellent work digging stuff up. It's great.
Here's another one McToon has on his site. This is a freaking joke. Empirical modeling of refraction error and trigonometric heighting using meteorological parameters. Okay. Yeah, so that's what they do. They take they make meteorological observations and survey observations at the same time, and they're uncorrelated.
I know. I'm just laughing because the data fitting is so egregious.
Here's the observed, right? There's the meteorological observed and the frickin' the survey observed. Those fucking lines aren't correlated. And then they try to estimate K from it using like a model, right? Different models to try to create a correlation by basically making a filter.
And then you see those models tested.
Yeah, and I'll show you.
They collapse.
And this is what spits out. The survey observed is the dark blue line.
So there are a couple papers on this that from hashtag Geodesy in the home server that I think you'd be that I direct your attention to first and foremost, and that'd be the NATO Sapphire trials, the German and Dutch.
That's what I want to get. Yeah, I want to look at that big time. I saw that. Now, what was that about? Give me like the short version, Cliff Note version.
Dutch team, Chesapeake Bay, 16-kilometer observations shore to shore. One side, German team too. One side had an infrared TV.
No, I'm just kidding. Huh? I said, who let them in our country? No, never mind.
NATO. It's for a Navy contract under Navy funding line, NRL. But so they set up an infrared camera TV, and then they set up lights on the opposite side on a tripod, and then there's like a Yogi Bear Ranger tower that they set lights graduating up in elevation.
Yep.
Dutch team found that they had to. So they required 0.01 degrees Celsius precision for their model to work. And their model failed, and to make it work, they had to widen the error by 1 order of magnitude.
Yikes.
That's what the Dutch team did. German team was railing about how confounding it was that the lower light on the tripod that was supposed to be a control for Earth curvature, because they purposefully, specifically took the Earth curvature calculation and affixed the height of the light to be beneath the curvature of the Earth. I checked it myself with the math, and that's exactly what they did. They were spot on. And they could see the light in basically all conditions. Day and night, they could see the light. Rainy weather, not rainy weather. And they called the situation cursed. They actually did in the paper that they furnished to the government. They also said that they could not actually detect or measure where the Earth curvature was, even though they knew where it should be. Great quote in that paper, by the way. Box Ops took it, made a meme out of it, which is awesome.
God, we have so much good crap, dude.
Yeah.
We do. Like, that's another awesome one. Like a treasure trove. That's why that dude Barron last night, that's what ticked me off when I actually came in here. I was listening on YouTube, and then I heard him say, well, flat earthers say, do your own research. But you guys research the wrong thing. You go out and you watch some YouTube video or something stupid like that. You guys don't do anything actually for yourself out, and that like flamed me, dude. I was like, what? Like, you don't know us. Anyway. Yeah, dude, we do the best research. What are you talking about? We do so much research that you aren't aware of even within your own field of supposed expertise.
Yeah, it's like our community produces the content that people watch on YouTube.
Yeah, Indio, as soon as you joined the chat, I said, oh, shit.
Yeah, I mean, I was civil with them. I shouldn't have been because that kid kept talking over me. He was being a jerk. But he was trying to filibuster. I know what he was doing. But I'm not going to let him end up being the center of attention.
How many hours ago was this? I want to listen to it.
Oh, what was it, like 2 a.m? Yoder listened to it. What, when... Did you listen to it last night or in the stream?
Last night. Let me pull up YouTube. It's still going to be where I left off.
Oh, cool.
Yeah, it was about 12 hours ago.
Maybe a little bit more than 12 hours ago.
Awesome, thanks.
Because I know I stayed up past midnight my time, which was 12 hours ago, to keep listening to it. So maybe 13 hours ago.
Still waiting for the answer to my question. What's the reference ellipsoid for? You notice, right? He started saying he measured an ellipsoid. Remember, Yoder, with you? Somehow
you did.
measured in the real world an imaginary mathematical surface.
This is how I know he doesn't know what he's talking about. He says all surveyors are geodetic surveyors. And then he goes on reifying the model. Like, take one class, the Introduction to Geodesy, and they'll tell you that WGS 84 is a mathematical datum and it's not real.
He should know that. I'm going to ask him. He said he's doing a stream tonight. Maybe I'll go on and ask him. I'll straight up ask him. I'm going to ask him if China uses the WGS 84.
Yeah, good question.
It's like illegal, isn't it, in China if they don't use their own?
Yeah,
that's right.
That's what Yoder was saying.
Let me pull up a link to that article on geodesy.
Well, I mean, if he says no, they don't use the WGS 84, it's like, so they're not measuring the Earth. You said you're measuring an ellipsoid, so what's China measuring? Because the ellipsoid you think you're measuring is a WGS 84. And if they're not using it, what are they measuring over there in China? I'll probably get kicked after that. I might not want to say that. I was getting straight up booted.
Oh, it's not in the server. I thought I posted it. Hold on.
Yeah, DJ, the first question I asked him, I said, I just want to know, what's the reference ellipsoid for? He never answered. I said, because Earth's not a perfect sphere. Yeah, but if you're measuring curvature, what do you need it for? Can you get rid of it and still measure the Earth to be a ball? Like, why are you using it at all? Jesus Christ, man. I can't believe you actually got that out, Yoder. And it didn't freaking nuke you.
That's crazy.
Yeah, for spam.
Map says weapons. Yikes. Map says weapons on TikTok.
That's such a such a huge like, if anyone denies that and then you drop that list of links and stuff. It's a killer citation. A bunch of citations. Nice.
I wonder if you go to be re-educated if you get caught with a theodolite without permission. Drop that theodolite. You're mapping stuff without permission. How dare you? Map materials are not allowed to leave the country.
Yeah, they talk about the government doing critical offsets to conceal national security interests, all kinds of stuff.
Are they?
That's what they say.
Yeah.
Witness.
It's just using freaking a different Earth model. Different datum, right? It's going to just, if the datums don't, transform into one, into the other.
Yeah, gotta go. I'll be back later.
All right. Peace, man. Thanks a lot. I wonder how much this is just fear porn. Dude, Ray, what's up with that cat, man?
The squirrel.
Or the squirrel, man.
Yeah, it jumped up
What
on the
the-
rail, and thankfully it stayed there for a few seconds.
What the hell was that? Dude, I thought when I was looking at it before I looked at it bigger, I thought like your camera pros. Cause like he went into statue mode. Wow. Wow, what a great shot.
Yeah, because that kind of debunks the entire narrative that what we're seeing out in the distance is reality, when in fact it's
That's not a squirrel.
practically a
That's
mirage.
bird. Yeah, the Glober's gonna say it's a bird, man. What are you doing, fake squirrels? It's a bird. He flew up because he didn't want to get hit by the car. So he just hovered there, and the car went underneath him. And then he jumped off because he didn't want to get hit by the truck. Isn't it weird how are those the same distances? The truck and the car? Are those different cross?
Yeah,
Those cross the tracks at different
the
distances.
crossing is about 510 meters away from the camera, something like that. In the
But both
500
of
meter range.
those. So a car comes from the left or something does, and then the truck comes from the right. They're the same distance away?
Yeah, they're using the same crossing.
Wow. That's super weird.
Yeah, I would have captured more that day, but the battery on my camera was quickly died because I hadn't recharged it in a while. So, but I'm glad I captured that much.
Yeah, it's awesome.
Let me
I don't even know what
link
to say about that. I got to think about this for a while.
Yeah, let me link the entire video here.
Freaking squirrel, man. So
It's only
he's
like
on top of the metal railroad track? So that's where the track actually is?
Yep.
How does the cars look like they're going? Wow, that's a weird effect. I'm
Yeah.
having trouble wrapping my brain around this, man.
Yeah, because it's not the typical view that we see as bipedal entities standing upright. But that's a squirrel eye view, or more like a slug eye view. But
So hypothetically, if there was somebody standing where the squirrel was, their feet would be right there where the squirrel is.
yeah,
And it would look like the truck is coming underneath the person,
yeah, potentially.
about to hit him in the rear end or something. Yikes, dude. Pull this video. Quite interesting. Thanks for posting that. That should make my day.
And essentially, I picked that set of rail there because it follows the same ratio as when I look across Lake Ontario. Because it's usually I do like a 2-meter observation height for a 50-kilometer distance. So this rail is 2-centimeter height for 50,000 centimeters or 500 meters. I only wish I had a camera jig or dual cameras so I could capture a smooth transition, or the dual cameras would actually work better. I could have one at the track height, one 2 feet higher, and then capture the exact same image at the exact same time at 2 different heights.
You there, Indio?
Yeah, I'm here.
Yes. So Jesse and Ruhif, right? They say that every single observation when you go up to a certain altitude just perfectly matches with 7/6R,
Everyone?
which is crazy. Yep. Ruhif said everyone.
That's a fucking bold claim.
Yeah, and they challenged.
That is a really bold claim. Oh, now I have to find an example of that not being true.
So they're saying that refraction happens 24/7?
7/6R all the time once you get up past a certain. So they said, I bet you can't find one example where that doesn't happen. And the Pete Gaspard, the Canigou to whether he's looking over the French Alps and you can see all of the different mountains. He's got the panoramic view. The horizon should be at 117 miles away, which is kind of where the water and the land start to meet. And once you add the 7/6R to it, it only takes it to 125 miles. And there's no sign of a horizon there at all. So that alone debunks that claim that that would always be the case, right?
Yeah, that's a
and then all of a
which
sudden,
one you talk about? Are you talking about the black and white one, or which one?
Yeah. The infrared one, 1,000 nanometer infrared.
Okay, so what's the furthest distance on that?
Well, the furthest
doesn't matter.
So, I'll post it.
Here, because I'll use Mick West calculator. It has 7/6R built into it. So hold on.
Yep. Observer heights 9,136.
Oh, there we go.
Feet.
Okay. So the refracted horizon distance is 126 miles.
Yep.
The unrefracted is 117. So.
All right. Now I'll bring up the image, and someone's made a spreadsheet of it as well. It's got the every single mountain peak distance, and they've calculated the hidden height and the visible height.
I did do that at one time, and then I accidentally deleted it because I thought someone was in my email. I started deleting everything, and I'm like, shit, why'd I delete that? Dude, I went and did every single peak. It was like 200 and something peaks, man.
Yeah, and I've heard them that some of the peaks are not measured properly, right? That's their excuse anyways.
This is so basically, yeah, so I'll just post the image.
I know which one you're talking about. I've seen it quite a few times.
So I'm not even, oh shit, hold on 1 second. 30 megabytes.
Gemsy used to post this image quite a bit.
Yeah, definitely. So I think it's the best part about it, right? Because once it starts to get to the mountain ranges, it's kind of we can't really see the basis of a lot of the really distant peaks very well. But the horizon the actual physical geometric horizon that would have to be there on a globe would have to be at the distances that Indio just mentioned, right? If they're claiming that 7/6R happens, right, all the time and it's reliable, and we can't find a single observation where it's not that, just the horizon not being there debunks that claim. Oh, yes. Awesome. I was going to do this.
Look, you could actually. So I have a full panorama of this. It's like 93 megabytes. Hold on a second. I'll post that so people can look at it. It's what was it? What did I name that shit? Can't believe I'm still on this shit after all this time. This ain't a dead issue.
The horizon changes by the day, by the hour, right? Like, fuck.
Here's a like a close-up pan of the panoramic shot. We can see the shoreline very nicely. So if we have a look at the image above this,
what I wanted to point out is you can see. So there's windmills on the other side. You can see the windmills. They're 8 feet above sea level.
Those are 8 feet above sea level?
Yeah.
That's awesome.
Now you're looking at the hubs, though, so it's hard to tell because it's so far away. But obviously the hubs are not on the shore. But I think
close up of the windmills.
The line of dots. You know what I'm talking about? Okay.
Yeah.
There's also 3 towers that you can also see. Now, I've also managed to work out, though I can't show my work because I did this quite a long time ago. That's why I'm like, this shit, I can't believe this shit's still alive as an issue. That this image, the panorama, spatially is vertically compressed relative to the horizontal. And the way I figured this out is, so what I did was I took 2 points I could find on the map, right? And I did this circle thing. And then from that, I drew a line to each point. And then I take this circle, throw it in GeoGebra, measure the angle, right? I know their distance, their ground distance, say, I think it was like 2 miles or something. So I can now equate the angle to 2 miles. That's the horizontal distance. Now I can, and then I can convert that into a pixel count. 100 pixels is 500 feet, say. Then I can do that. Okay, so if 100 pixels is 500 feet, I'm going to count 100 vertical pixels, right? And see if that's 500 feet of one of these mountains. And it's not. They're compressed. And this isn't an earth curve compression because I'm using a part of the mountain that's visible. You know what I mean? I'm not like doing like the entire mountain, like, hey, from this part of the mountain to this part of the mountain is so many feet, right? So I can extrapolate, count the pixels, how many feet should it be if I use the same horizontal scale? And it's less by 10%. So there is some sort of compression going on even in infrared. It's just not as severe as the visible light, which is way more severe, which I also have pictures of. I have you seen that, the pictures I've shown of? It's like a visible light one and an infrared one, Mount Ventoux.
I have.
Yeah, I can find it.
Yeah, I got it here. I'll post it in the side chat. Let me know if it's the right one.
You do have it or not?
Yeah, I do. Is it this one?
It's a double image. It should be like a color. Yeah, that one. Yeah, that one.
Oh yeah, that's a good one. Damn,
so if you try to line up like the tops, then the horizons don't match, and then if you try to line up the bottoms, then the tops don't match because the visible light one's compressed. And it's not compressed from Earth curve. Okay, it's not because we'll try to take that compression, and because people usually like, hey, dude, like things get compressed with difference. They're like, no, they don't. And this is why I have this, because this proves, yes, things do get compressed with distance.
Yeah,
that's why the thing I'm talking about. That's why I did all this, right? That this vertical scale, horizontal scale thing, it's been like, I guess it's just been assumed that these. I mean, there can be other factors. It could be the sensor, because the sensors are not always scaled properly. You know what I mean?
Could it be something to do with the focal length as well? Because these look like they're at completely different levels of zoom.
They are at different levels. He was zoomed out. I don't know how the focal length would really change one axis. I don't understand how that would change, like how one axis would look.
Yeah. I just know, you know how, I don't know, you've seen those images where they change the focal length and things in the background all of a sudden look way bigger than what they look when you have a lower focal length.
but those are like close relative distances. So it's like 40 feet versus 500 feet. You know what I mean? This isn't like, zooming, like changing the focal length at an object. Because that's called like depth of field. I know what you're talking about. It's like depth of field. It's so geometric. Like the difference in changing the focal length of the camera relative to the distances they're photographing is insignificant. It's in the millions or something. Oh, I zoom the camera out,
I'm more interested in the closer things. I mean, that we can really distinctively make out from bottom to top. That would have to be behind that geometric horizon.
Yeah.
So in that image,
well, just to let you know, there's a whole mountain range, right? Like if you look at the photo, the double photo you posted, the infrared, right? So there's the Alps are in the back, right? But in the front of those, there is an entire mountain range. Those mountains are like 1,200 meters.
Yeah.
And people are like, why can't I see the bottoms of the mountains? Like, well, there's mountains 1,200 meters high in front of them. Because if you look at the map, you go on Google Earth or look at Google Maps, it shows mountains in front of the Alps in that line of sight. And they're 1,200 feet. You can just do the elevation profile, right, in Google Earth. I'll just do it right now.
Man, who went to the effort of making all these little black lines with the names? Working out what every single one of these mountains is. Shout out to whoever did that.
There's an app for that.
Ah, okay.
Because it'll take a photograph and you say, oh, identify these mountains, and you tell it the general area, and it'll start labeling for the peaks for you.
Oh, that's
this is the elevation profile, right? So you see there's a bunch of mountains in front of the Alps. Those aren't part of the Alps, that little bit. There's like a bunch of mountains, a little plateau, and then you like go up into the Alps. That flat part's the water, by the way. Just so you know.
Awesome.
Yeah, I examined this area pretty thoroughly. I know this area better than any place in the world from looking at maps and shit. Since we're talking about this, I might as well bring the skeletons out of the closet. Might as well.
Yeah, I want as much info about this as possible. This one, because this is a killer. This shuts down Jesse and Ruhif's challenge, and I'm gonna make a detailed video about this observation. Do it as well as I can, putting it all together, explaining it all, and.
But there's all the Canigoo photos. The horizon's in the wrong place, right? Peak Fenestrel. You know.
Yeah.
Because you got to remember, Peak Fenestrel is even further away. Peak Fenestrel is behind Canigoo.
Is that the one that says max distance?
Yeah, that's the 443 kilometer one.
Oh, that's the 443. Yeah. What's your rebuttal to? I see the anti-flat earthers. They're putting up that world record one, and they're saying that because a mountain that's closer appears like it's higher, it proves the globe.
Yeah, I've heard them say that.
Yeah, it's like you can see the mountain. Maybe it's Gaspard in the background, but they're like, "Oh, look, there's this other mountain it's like 100 miles closer, and it's shorter, but look, it looks like it's higher. Therefore, the Earth's a globe."
Yeah, that's a bar. I think. I'm scrolling up. This is some old stuff, man. I'm like scrolling way deep into the archive. There's digital dust flying everywhere.
So even with refraction, like the 7/6 are factored in, the horizon should still be over the water. That's crazy.
Yeah.
That's awesome.
There should be a water horizon in all those Canigoo photos and the Peak Fenestra one.
So that means we should just see a line of water and then see the mountain peaks popping up over it.
Yeah, see stuff starting to stick up from behind the horizon, right? Behind the water.
Yeah, and that's taking their bullshit refraction into account. So what are they going to say? You know what Jesse actually said? He said, "Oh, like all of a sudden," he said, "Oh, maybe the water was really cold that day."
Oh my goodness gracious!
But all of a sudden now, like we got to get up really high to avoid the the hectic refraction down near the water. Now all of a sudden the water is playing into account again. And then he said, well, actually, like maybe the horizon, the geometric horizon is there amongst those mountains. And how would you know?
Well, what it should look like, right? Because like the circle that I drew, part of it's in the water, part of it intersects land, right? So that land that it intersects should look like a peninsula from the point of view of the camera. And then it should stop and then start to be water with things sticking up from behind it. But that's not what we see. We see the shore.
Great point. Yep.
Oh. Is this it? I got some pictures of the windmills. This one is the line of sight showing the distance. This last one I posted to where the windmills are. It's 133 miles.
Well, so this is those windmills that we could see lined up in a row. Is that what you mean?
Yeah, yeah. And this is the angle that it's looking at them at.
Okay.
So it's not looking at him like sideways, like, you know what I mean? Perpendicular to the row.
Uh-huh. Save this one as well.
That's why they kind of look like they're close together. Because it's, you know, you're kind of looking at it at an angle.
Yep.
Yeah. But this water is like a canal. This isn't a river. And I think its elevation is something like, I'm pretty sure this elevation spot was like 8 feet or something.
So this line is showing the distance to the observer, is it? 133 miles. That's how far away the cameraman is. Is that right?
Probably have stuff on the height of the windmills. I certainly do. I really have to find that. That was actually pretty hard to find. I do have the weather conditions for that day. You want that?
Oh yeah, man. Anything you've got. Where the conditions
We had
would
like
be
a French
awesome.
flat earther, dude. I had them find it. Because it's France, right? Like, they found it for me. Like, fucking awesome.
Yeah.
It
Yeah, if
was
I
a
could get
girl,
the
a
height
French
of the
girl.
windmills, if I need something that I can focus the observation on, the windmills
Well,
would
I
be a
got the
great
weather
thing.
conditions for the time the fucking photo was taken. The actual weather conditions. So I can find them. Imagine them having that. Imagine them having anything. I'm getting close. God, who's the idiot who organized this junk?
Yeah, one time I was having Gemini look at one of my photographs. I told it what the date and the time of the photograph was. Automatically brought up all the weather conditions, including the water temperature, which I never asked for.
Really? I have to.
Yeah.
I have to do that. It didn't work.
I'm just gonna paste that into ChatGPT and tell it to find me the height of these windmills. see if it can do it.
Yeah, I have the height somewhere. I just have to. That's probably on the main server. Right now, I'm looking at like I have a little storage Discord that I put stuff in. I don't think I have the heights of the windmills in that. Okay. Make sure it's the right one. Yeah. Yeah, this is it. Okay, this is the pressure that day. Right. So the day they took the photo was they took the photo after midnight, 4 in the morning on the 13th. So if you notice, you have extremely high pressure on the 13th. And between the 12th and the 13th, extremely low humidity. That 22 humidity, that's unheard of. And this isn't even at the top of the mountain. This is just at the closest area that's like a city where they track weather.
Yeah,
to
closest weather station.
to Canigoo, right? So it's at the bottom of the mountain. Which is it's right near the water there. And so if they had like 22% humidity down there at the bottom of the mountain where the water is, can you only imagine what was on top of the frickin' mountain?
Yeah, I think the photographer said he waited a long time to get such a day like that. It's on the website.
I have his email, by the way. I talked to him. I talked to him once.
Oh, wow.
But I asked him about a different photo.
All right, so ChatGPT. So first it said, no, I can't help you. I can't find it. I'm like, hey, put some effort into it. I'm like, study the name on the map.
Stop being lazy.
Yeah. And now all of a
Use
sudden
more
it's
tokens, damn it.
Yep. So now it's told me the area that it's in. It was able to find what the name of that canal is. It says ground elevation at Fos-sur-Mer area is very low, largely near sea level, with typical values around 9 to 10 meters above sea level. 49 meters at the highest spots inland, but because of the location you measured is right next to the canal/port, the ground elevation at the site of the turbines is less than 10 meters above mean sea level.
The value I got was 8 feet, if I remember correctly.
8 feet?
Yeah.
Well, now I know the name of it. I can just check on I'll just check on that.
You can tell DJ has a history of managing people. Come on, man, put some effort into it. Be honest with yourself.
The AI gets lazy, man. That's what I noticed recently. Like if I tell it to put extra effort in and I'm really counting on it, it puts so much more effort in than if I don't say that. It's crazy.
You think that's
hey, but you got to be careful though, because I'm sure there's plenty of workers out there that'll lie straight to your face. Yeah, I did it, man. I did it. I did what you said, and blah 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 blah. They just fucking do
it. Yeah, man. Without a doubt.
I think they got lazy mode. They like flip the switch. Be lazy unless they specifically ask you to stop being lazy.
Yeah, try to be more supportive. I know you can do better than this.
Oh, I'm very nice.
DJ's going to get an email from ChatGPT HR.
Stop bullying our chat agent.
No, always make
We've
sure.
received a few complaints from ChatGPT.
The elevation profile or the elevations that you get on Google Earth are all over the place sometimes, and same with if you try to put in like a coordinate, of say a buoy, for example, right? Because remember Indio, how they were criticizing, they were saying, "Oh, we put in the coordinates and the buoy has to be at this lat long." Right, and because the buoy's at this point, we can tell that the boat must have been a mile closer than what you're telling us. And then when I looked up how much the margin of error is on the coordinates, in some places on Google Earth and Google Maps, it said, oh, they can be off by huge amounts. And same with the elevations as well, because it's changed, right? I don't know what they did, but if you go to where they did the Black Swan, right, like that whole beach, Miramar Beach or whatever it's called, if you put the elevation, like hold the mouse near the edge of the water, it's 5 meters. It says 5 meters, and if you
5
drag it up,
meters? Jeez.
it says 5 meters. Yeah,
A little cliff there. Did they do cannonballs off of that?
Yep, and now it
That's
says
crazy.
that the point where where he did the 8-foot observation of the oil platforms, it says 9 meters, but it's only 7 foot. It's only 7 or 8 foot, but it says 9 meters. So the Globers were trying to call me out that he was lying about it, and he fudged the numbers because it literally says that. And then, but I didn't notice at the time. You drag the mouse lower down onto the beach near the water, along the whole beach. It says 5 meters, and then I looked it up. I'm like, how come it says this? And it says, oh, sometimes they change the sources, or they change the elevation profile maps or something like that. And in low light, like in coastal areas, it can be off by many meters.
Yeah, that was pretty low. Accusing you of lying. It's messed up, man.
Oh, dude, they were desperate.
Did you I posted in here, I think you were in here. McToon on TikTok?
Oh, against Angels of Light?
Yeah. Yeah.
Yeah, that was funny.
Oh, you saw that? Straight up lying, dude.
Was he
red-handed?
Oh, yeah. Yeah, was that the one where he kept calling angels Satan?
Yeah. Yeah.
That was a massive meltdown.
And then he's like, yeah, I have that paper. Paper had nothing to do with the spin of the Earth. It was about measuring little g. Ridiculous.
Man, I found a random clip of McToon on my other computer the other day when I was cleaning it out. I don't know, I must have saved it sometime. And McToon was going on about how some flat earther had his kids taken or was during a divorce or something like that, and how he was saying the flat earther should never be allowed to see his kids again because he's a flat earther, and that he should have his kids taken away. This is the craziest. Yeah. I gotta find the clip. It's on my other computer. I just got to copy it off it. But I
think I underestimated his mental illness, and
yeah.
Considered him like a rational actor to some degree. I knew he was a little fruity, but maybe I need to reevaluate. What does that say about the people that follow him? My God.
It's the most degenerate audience that he has. I mean, he was doing that furries around the globe video, which was weird, right? And then there's all furries in the comments saying, all right, you gotta, all right.
No, I don't. No, don't do it, DJ. I don't.
Oh, no. This has to be done. Because I got screenshots as well. All right, so I'm gonna post this and then 2 screenshots. All right, you already had a low opinion of McToon. Just get ready.
Yeah, you just gotta search furries on his profile and it comes right up.
Oh, no. This can't be real.
All right, here it is. And then I'm gonna find these screenshots of him replying to messages. Okay, so here's the video. Why would you?
What the hell?
Furries around the globe. It's a song.
It's a song?
Yep.
What? Oh.
Now, I'm not gonna lie. I've never watched the video. I just know it exists.
It's literally like furries dancing around and stuff like that. And it's called Furries Around the Globe.
Oh my God, it's cringe core. My God.
Yes.
What? No. No.
Mormon.
I want to be plugged back into the
watch.
Matrix now. Thank you.
All right, here we go. Screenshot number 1. Okay, so Skeptical Shelby says, "Wow, I thought I was the only furry in the debunking community. I'm thrilled to be wrong." And then McToon hearts it and says, "There are a good number, it seems." And then the next one is this is.
Oh my gosh, dude!
The next one's better. This one, have to admit, wasn't expecting to find furry content on your channel, but hey, I can't say I'm complaining. McToon hearts it, right? It's also got 6 thumbs up, right? McToon hearts it and says the furries are coming at him first. I would like to be the first to welcome you to our new furry overlords. And then someone says, McToon, you have done very well. You will be rewarded.
Oh my gosh, dude. Well, Gem Panda server is a furry server.
So yeah, Toons. It seems Toons a furry. I think we can say that. There's tons of comments in the section where he's basically like talking about that. There's lots of furries in the debunking community and welcoming them all. So yeah,
dude, that explains a lot.
Yep. So yeah, completely
dude,
mentally
Muppets aren't furries, dude. What are we talking about? Okay, let's get back on topic, man. Ugh, gross, dude. What's going on? I'm dumbfounded. I can't, like, my brain can't work now. You messed it up. So we got this zoom in on the windmills. I don't know if you saw that picture. The zoom in there. And
yeah.
There's something sticking out over here. I'd never noticed that before. On the shoreline. But that's good. You know why? Because we can find that. And if it's a rock or something. Or a boat. Because the horizon's supposed to be like 120 something miles. And I'm pretty sure those windmills are quite a bit further than that. Well, 137. Right? So 10 miles further than the 127. 126.